In section 1.4, they don't just call it angles. They talk about measuring angles. Well, what that entails is we have to be able to define a bunch of things, know how to label them, and go from there. For the most part, what happens, put that away, please. For the most part, what's happening is that I'd say 90% of the stuff we're going to talk about today, you already know. There may or may not be one or two things that'll be a little bit different, a little bit new. But for the most part, this is all going to be reviewed, okay? Because I know all of you guys have dealt with angles before. You know how angles are made up. You know what the parts are. What's going to be new is going to be the way we label them and a little bit of the algebra. But you'll find out the algebra is going to be just like what you did yesterday. It doesn't change, okay? So an angle. As you start thinking about it, what is an angle made up of?
Lines.
No. What are they made up of? Rays. They're made up of rays. Angles are made up of rays. Why are they made up of rays? Yes, sir. Exactly. Remember, rays, and you're right, start from the same dot. The rays, just like we had, remember yesterday we talked about what are called opposite rays? They had a common endpoint. Angles have a common endpoint, but not only can they go straight, they can turn. So angles are just rays, are just two rays, or excuse me, an angle is made up of two different rays with the same endpoint. Now, what we do here is angles are made up of two different rays that share a common endpoint. In this example here, I just drew a little quick angle, ABC. What is the common endpoint? B. B is the common endpoint. What do we call that point in an angle? Do you know? Sure you do. The what? Excellent. It's called a vertex. The vertex is the point at which the angle, or excuse me, the rays meet. The point where they meet is called the vertex. It's called the common endpoint of the angle. I know a lot of you guys know this, but come on. The rays meet at the vertex. And then the last little bit here, I think I talked about the sides. Yeah. Honestly, the sides don't come up too often in really much, but the sides of an angle are just the rays that create it. All right, I wouldn't really worry too much about that definition, to be honest with you. Now, the way that we talk about angles is that we have to be able to understand how we label them. Now, when you label angles, how many points are there that create the angle?
What did you say?
How many points make up that angle? 3 of them, okay? So when we label them, we use all 3 points. Now, I use a little bit of a different angle symbol than what the book does. The book uses just that, just fine. When I grew up, I was taught that it was an angle with a little bit of an arc. The reason that I do that with that little bit of an arc still is because it no longer looks like a less than symbol. And as you get into Algebra 2, you will find out that angles can be created out of what is called the unit circle. And within the unit circle, as parts come out of there, there are arcs that are created. Do you guys know that a section of a circle, like on the circle, is called an arc? Have you heard that before?
You taught us athletic.
I'm so glad you were paying attention. Erica. He wasn't very enthusiastic. Come on. So that's why I was taught to put that little arc in there, because eventually it will be part of a circle. Worry about that now. You've got at least a year and a half before we have to worry about that. And then when we talk about it, we just say it's angle A, B, C, or you can say that it's angle C, B, A. What's consistent between those two write-ups?
B is in the middle.
Why is it in the middle, do you think?
Because
It's the vertex. Very good. No matter what, the vertex of an angle, when you label it out, is always going to be the second letter. Always. Always, always, always. That will never change. The other ones just tell you what direction you're walking. Are you walking from the top down? Or are you walking from the top, or excuse me, from the bottom up? That's all that means. The directions of the letters just tell you which way you're going around the angle itself. Okay. There is another way that you can label angles. If by chance the angle can only be labeled with one possible vertex, you can use one letter. I could say angle B for this one because there's only one angle B. You're right. Unless I did this, I can't say angle B for that one because if you look, how many different angles are created there? 3. You guys see that? There's 2 smaller ones and a larger. I can't use one letter for that one. All right. So angles, you're basically going to get you'll see more often than not, you'll see it written as 3 letters, and really all the 3 letters tell you is what direction they're going. Where are you guys playing today? Where are you playing at? Which sports are you playing? That's a nice course. I like that one. Good luck. Golf. Not so bad? Like I said, this is absolutely nothing new for you. The only thing that was new is probably the symbol that I use, and just remembering that the middle letter is always going to be the vertex. Types of angles. You know this. Ooh, which one? What's that? Okay, we'll get to that, but I'm looking at classifying the angles. Very good. That's what as soon as I said a classifying, then you guys, oh yeah, that's what it is. Yeah, so you have acute. You have obtuse, good. You have right. Are you guys okay with me just using the abbreviation RT angle?
No.
Well, you'll have to get over it because that's what I'm going to use. Not changing.
Wait,
Right angle. And what's the last one?
Right.
You have right angle.
A circle. No, is it straight?
It is straight. Very good. Left angle. All right. What makes an angle? What makes an angle acute? Thank you. You were paying attention. Less than 90 degrees. Okay. Can it be -7 degrees? No. Can you have negative angles? No. All right. Let me rephrase this. Can you have negative angles in geometry?
Yeah.
No. No. In geometry, we will not deal with any angles that are less than 0. Okay. Basically, our angles for acute are going to be angles that are greater than 0, but less than 90. Okay. They're going to be greater than 0, but less than 90. They're not going to equal 90, and they're not going to equal 0. In algebra 2, you will have negative angles. Negative angles just mean you're going a different direction. Okay. When you get to algebra 2, you'll have the XY grid. It starts at 0, goes 90 degrees up, 90 degrees down, 90 degrees down, and 90 degrees back up. So you start at 0, and you go 360 degrees. Make sense? What happens here is a positive angle goes counterclockwise. A negative angle just goes clockwise. That's all that means. You will spin to place it within a quadrant, and so on and so on. So negative angles do exist, but if you ever get an angle that's negative in geometry, you screwed up, figure it out. And I mean that nicely. But yeah, there's no negative angles in here. Okay.
Okay.
What is an obtuse angle? More than 90, but
Less than 180.
less than 180. Good. So an obtuse is going to be an angle that is more than 90, but less than 180. Which leaves us the last two, which again are super, super easy. 90 and, very good. You've all seen that symbol before? The little box. And then the straight angle is going to be the angle that equals 180. Ooh. Am I going to yell at you if you forget to put a degree symbol? Nope. 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 Nope.
Will you take points off?
Nope. For real.
Mr. Jeffrey.
Well, he's a meanie.
Do you say he's mean or isn't he?
He is a meanie. He's just Mr. Meanie Magoo. I'm just a wonderful human being.
Are you
Nah, not really. But in all honesty, guys, if I get you to understand the concepts and you know how to work with them and set things up and not have a big deal, is it the end of the world if you don't put a degree symbol?
No.
No, not at all. It really, really isn't. The only time that I'm going to be a stickler when it comes down to labeling things to make sure it's correct, surface areas, volumes. You know, so many square feet, so many cubic inches, things like that. That's really the only time I get really, hey, make sure you have it labeled correctly. Otherwise, whatever. If you can math, you're fine. Okay? And we talked about how a lot of times in math, you can get the wrong answer because you wrote the wrong number down. We talked about that? It's the same thing. If you wrote down the wrong number in the middle of a problem, but you didn't do the math wrong, you're not wrong, you just wrote the wrong number, or you flip-flopped numbers. It happens all the time. That's why it is so important you guys show your work whenever you do stuff, okay? I know a lot of this stuff can be pretty easy, but if you show your work and you screw up, I can figure out what you did wrong. It becomes really huge when we get to trig stuff. That. Oh no! What does this look like?
Arrow.
That's circle.
It looks just like segment addition, doesn't it? Two smaller angles make the larger. It's the same exact thing. It's the exact same thing.
That's what it's called, isn't it?
It's just like segment addition. Just like we did 2 days ago, we did this.
Oh.
Now what we're doing is with an angle. It's the same, it does the same thing. So it's going to be the same exact process, the same exact steps. The only thing that's going to be different is that it's going to, when you write it out, it's just going to be a couple extra letters. Really. Okay? What happens here with segment addition is that if you have two angles that have a common vertex and a side, you can add them together. You have two angles with a common vertex and common side. That's when you can use angle addition. What I mean by the common side is this. It's shared between both the two smaller angles. That's what that means. That's it. That's what the common side means. Okay? So in not so many words and stuff then, when we did segment addition past couple of days, we would say two smaller chunks add up to equal to the larger. Like for example here, I had xy plus yz equal the whole thing, xz. Here, I just have it in terms of angles instead. And when you write out angles, there's just more letters. The math, the statement, everything else is all the exact same. Your workload just increased by writing down extra letters. I'm trying not to make this really hard on you. Okay? For example, I can say, let's see if I can make this work here. Let's see, I have angle ABD plus angle DBC have to add up to equal which angle?
ABC.
Exactly. It would have to add up to equal angle ABC. What do all three of those angles have in common? B is in the middle, B is the vertex. And it should. If you can write it out like that and you wind up with the same letter in the vertex, you can add them together. Could I add 3 angles together? Yeah. Could I add 4 angles together? As long as they're all sharing the same vertex and you just move it right next to each other, it's going to work just fine. Yes, sir?
Is B like the midpoint?
It's not the midpoint. The B is just that common vertex. It's just the common spot where the end point of the rays are. We will at some point have a midpoint-ish thing that's called an angle bisector. Because an angle doesn't have a midpoint, it would need something in the middle of it to cut it in half, if that makes sense. So if you have a 90-degree angle, what would be half of 90? 45. So 2 45 angles would add up to equal a 90. That's what an angle bisector is, whereas a midpoint is just the spot in the middle of a segment. It could also be called a segment bisector. Does that make sense? Good question. Okay. So, is anything going to change if I throw numbers at this problem? No, nothing. It's the same thing, you just have more letters to write. For example, hey, look, it's the same exact diagram. Convenient that sometimes I use the same thing that you probably just wrote. So you don't have to do things twice. You're welcome.
Thank you.
De nada, señor.
What?
He said you're welcome, sir.
Oh.
So you know all this is done,
I'm too busy learning.
Learning.
You're not learning.
Just not
That's
very
why I
well.
don't.
You're still talking to me
Just like I choose to make it look like I know how to speak English sometimes. So, like we did yesterday, I'm gonna start this problem kind of the long way, just because yesterday we did the same thing. We started out the long way by writing out all of the steps, writing down what segments make up the larger segment. We do the same thing with the angles, just to get a hang of how these things are built. So as we start to look at how these things are built, I know that angle ABD plus angle DBC has to equal angle ABC. Well, fill in the blanks. What's ABD? Plus something. What do you do?
Subtract.
And what do you get? 75. Very good. The answer. Very good. And that answer is? 75. And that's exact. Yes, ma'am.
Hey, why isn't it in red ABC when blue is ABC?
The ABC is the big angle. The ABD is this part. That's why. Does that make sense?
Yes.
That's it's you know what sucks about angles, there's so many damn letters. Seriously, that's the worst part of all this. I'm not gonna lie. It's so that's the major downfall of dealing with angles, is that the lettering gets messy. Other than that, I mean, everything else works the same. It's just the lettering. If you can get past and slowly walk through the problem and looking at what you got, you're gonna be fine. Just don't get lost in the lettering. Yes, ma'am.
Okay, so you know how you get that website that all the teaching videos on?
Yeah.
Okay, and the district season?
Yeah.
You know we just passed it.
No, I didn't.
You said,
I apologize. I'm sorry. Sometimes it slips out.
no, I don't care. I just want you to
Oh, thank you. I never brought up, but it just happened. At least I didn't say like really bad things. You know, and that's you know what? Yeah, like I told you, I record lessons. I post them on our website. I had a kid that was absent yesterday, in my second hour class that he walked he watched the video to get the notes and did his homework. He said that was awesome. You know, you can fast forward. You can actually watch you can watch YouTube video on faster speed. So my voice gets a little bit quicker. It's really funny. It's really, really funny. Do you ever go back and do that?
Right now.
No, I'm busy.
Do it right now.
No, I'm not going to fall to your peer pressure.
Do
it.
I don't like any of you.
Chuck is right there. No, you.
That's the end of the notes.
Yeah.
That's all?
Well, I'm going to do some examples now. That's all we have to worry about.
Examples?
I'm always good examples.
No, can we just start the 1 hour?
I only have a couple. All right. Now, second hour had this really tough time of reading the first line. Apparently, they all just said, what do I do? It's just 7x, 11x, and 9. I don't know what to do. Do I sound equal to each other?
Whoa.
Exactly. If you read the instructions, it tells you what things equal and what you're looking for. Take a couple minutes and figure it out. When you're worried about and working with angles, you can't just say ADC. You can't say that's the angle because ADC could be a plane, could be a triangle, could be an angle. You have to put the little symbol in front of it to show what it is. That's what tells you what it is. All right? Now remember, when you're starting with this, they're telling you that the large angle, ADC, is 135. That's this whole thing. That whole thing is made up of what two other angles? 80, those two. So you're writing out your statement that it'll be angle ADB, BDC, just like we did a second ago. You're starting with that scenario and then filling in the blanks. You know that you're looking at a diagram with two angles that make up a larger, so you write out what you have. Yeah. And then you substitute in the values that you know. Does that make more sense? No?
So like this?
Yeah, exactly. Yep. Yep. Now it turns into two separate equations.
Oh yeah, I forgot.
Okay.
We add those, right?
Yeah. What does it have to equal? There you go. There you go. Okay. So as you fill in the blanks, guys, you're going to get 7x. 11x plus 9 is 135. Correct. In this case here, you have to combine like terms before you do anything. So 11x and 7x is how much? 18x. Good. And now you are at a generic two-step equation. What do you do next? Subtract 9. Very good. And then lastly, how do you undo multiplying by 18? Divide it out. And was it 7, I think?
Yeah.
Now, the question didn't ask you to just solve for x. It asked you to solve for BDC. It's solved for this angle here. So what do I do with that value of 7? You're on the right track, yeah. You substitute in the 7 for x, and you get 11 times 7 plus 9. 86. Very good. Okay. You get 86. Notice, it's the same setup as you did yesterday, except it turns. It's the exact same setup when it turns. Okay? Yes, ma'am. Sure. Yeah, that's what the angle itself is, because you solve for x and you... No. What you solve for here is that this is the value of x. You take the value of x into here, in here, and figure out. Does that make sense? Remember, a lot of times in geometry, it's not just solve for x, it's solve for x and do something with it. Because they always have to add one. Because geometry is one step past algebra, so they have to add one step past the algebra.
Yeah.
They gotta do that.
At least that sounded good. All right, let's do one more. Oh, it's asking you to find angle P. Same basic setup, guys. Take a second or so. You'll be okay. Yeah. We're running short. What I have you guys working on this evening is I want you guys to do numbers 22, 23.
Okay, is that homework?
Yeah, it's already posted on the calendar.
What page?
I want to say it's page 30. And I posted it on the calendar already, but all I want you to do is there's 4 problems. 22, 23, 29, and 30. Alright, it's just angle addition stuff. For numbers 29 and 30, you'll notice, if you go up there and look at the diagram a little bit, there's 2 congruent angles. Congruent angles don't have tick marks, they have arcs in the angles to show them. Okay? So if you need to go up there, take a picture, by all means hop on up there, take it. Otherwise, it is on page, I can tell you, I think it's 34. No, I apologize. That is on page 32. That's on page 32 of your textbook. Okay? We got those 4 for tomorrow. Tomorrow we'll do more algebra stuff with this as well. We might mix back in a little bit of segment stuff, and we'll keep going. Yes, ma'am. Okay. What's that? So yeah, if you need to take a picture of it, by all means, I'll leave it up. Help yourself.